All right, let's cut right to it. We're going to break down how low-level design interviews are really graded. We're going to peel back the curtain and show you exactly what's going on in the interviewer's head. So listen up. If you think the goal here is to just jump in and start hammering out code, you're walking straight into a trap. Seriously, that's the single biggest misunderstanding, and it's the razor's edge between a pass and a fail. The code, that's the last piece of the puzzle, not the first. So, if it's not just about the code, what are they looking for? Well, it all comes down to this 6-point checklist. Think of this as the secret scoring rubric. From the moment you start talking about requirements to how you plan for the future, your entire thought process is under a microscope. And this framework, this is what we're going to master today. Okay, let's get into it. We're going to dive deep into this checklist, dissecting every single point so you know exactly how you're being graded. This is your exclusive look inside the interviewer's mind. First on the list, and honestly, this might be the most critical step of all, requirement understanding. Before you even think about writing a line of code, before you even sketch out a single class, you have to prove that you actually get the problem you're being asked to solve. And here's the thing you have to remember. Your questions are part of the answer. Are you asking questions to clear up any confusion? Are you digging for constraints? Are you already thinking about those nasty little edge cases? Look, this doesn't make you look weak. No way. It's the absolute signature of a senior-level engineer. All right, moving on to number 2, and you'll see how this builds on the first point, class design. So once you've nailed down the requirements, how do you actually start to model the solution? This is where they're testing your ability to create a clean, logical structure from scratch. You know, this part is all about the fundamentals. Can you look at the problem and pick out the core nouns, the key things in the system? And are you naming them well? I'm telling you, vague names like manager or data, those are huge red flags. Your class and variable names should tell a story all on their own. Okay, so you've got your classes. But it's not enough to just have these perfectly designed little islands. The next thing the interviewer is looking for is how you connect them. It's all about the relationships between them. And this is where your real OOP knowledge gets to shine. Do you know when to use an is-a relationship? You know, like a car is a vehicle. That screams inheritance. Or do you know when a has-a relationship is the right call, like a car has an engine? That's composition. Getting this right shows a level of understanding that's so much deeper than just knowing the syntax. Now for number 4 on our checklist, and this one is a biggie, design principles. The interviewer is asking a simple question. Are you just winging it, or is your design actually guided by proven, time-tested engineering principles? This right here is a massive green flag for any interviewer. Can you actually explain why you made a design choice using principles like SOLID? For example, just saying, I'm separating these concerns to follow the single responsibility principle. That shows you're not just guessing. It demonstrates a level of professional maturity that, trust me, companies are desperate for. All right, now we finally get to the part that everybody obsesses over. But notice it's only number 5 on the list, code quality. At its heart, this is all about craftsmanship. The whole time you're coding, the interviewer is thinking one thing. Could someone else on my team pick this up and understand it? Could they actually maintain this thing? Clean, modular, reusable code, that's not a bonus. It's the price of admission to a professional team, period. And that brings us to the final checkmark, number 6, scalability. This is all about thinking ahead. Your design can't just solve the problem for today, it has to be ready for whatever challenges are coming tomorrow. So, is your design flexible? Could you add a new feature without having to tear down the whole thing and start over? When you talk about how your design can be extended for future needs, you stop being just a coder. You become an architect, someone who's thinking about the long-term health of the entire system. Okay, so we know what they're looking for. Now let's flip the script. Let's talk about the biggest mistakes that get people rejected, and more importantly, how you can turn those red flags into huge green lights. The number 1 mistake, I see it all the time, is seeing the problem in just immediately starting to type. The pro move? It's to stop. Take a breath, clarify, design, then code. That sequence is absolutely everything. Another massive pitfall is only designing for the happy path. But what happens when the input's garbage? What happens if a service is down? The professional move is to talk about this stuff, discuss the constraints, state your assumptions out loud, and tackle the edge cases head on. That shows a really robust and thorough way of thinking. And please, resist the urge to show off every single design pattern you've ever read about. That's called over-engineering, and it's a huge red flag. A real senior engineer starts with the simplest thing that could possibly work and then makes sure it's easy to build on later. Remember, simplicity is the ultimate sophistication. Okay, enough theory, let's make this concrete. They're going to take a classic interview problem and see what this looks like in the real world, comparing a bad design to a really solid one. So imagine the interviewer says this: design a parking lot system. Simple, right? Well, let's look at how a junior level approach and a senior level approach would be totally different. And boom, here's the difference, plain as day. The bad design, it's just one giant parking lot class trying to do everything. It's a mess. The good design, it immediately breaks things down into the obvious pieces: a vehicle, a spot, a ticket. It's clean, it's modular, and it's a perfect example of the single responsibility principle in action. This right here is what a great answer looks and feels like. So look, if there is only one thing you remember from all of this, make it this. LLD interviews are not about your code. They are about your thinking. The code is just the proof, the final output of that thought process. So focus on the why behind your decisions, not just the what. Hey, if this was helpful and you want more real-world, no-fluff prep content just like this, make sure you subscribe. We're all about focusing on what actually gets you the job.